In this video for Computer Science 9618, we're going to be focusing on the AS level, talking about static and dynamic libraries, which could show up on the Paper 1 exam. But more importantly, we're going to write a VB.NET program implementing text-to-speech using a library. What are libraries? What do we mean by static and dynamic? What are these libraries that people talk about? Well, libraries have pre-written subroutines that any programmer can use in their program. It has pre-written code, and that's what I mean when I say pre-written subroutines. It has been tested and is frequently used by programmers. Think about math.round. Maybe you've had to write a program where you got to round to a certain amount of decimal places. This math in the math.round, that's the library, while the round portion is a subroutine belonging to the math library. Now, you don't need to know the complex code to round the number. You simply use the library. There's already code in the math library, specifically the round subroutine, that does the complex code for you. All you need to do is simply call that library. It does the code for you. Using libraries can save you time because the complex code has already been written, and it makes programming certain things easier. Now, you can also reuse your code in one program in a completely unrelated program. It can be used for more than one program. I can use the math library in any program I want. There's math.round, which will do the complex code that will round a number to a certain amount of decimal places. There's math.sqrt, which gives me the square root. It does a lot of the complex code for me, and because I'm not having to figure out that complex code, it's going to save me time and make certain things easier. Think about spell check. Here's another example. Did Microsoft write spell check for Word and then write it again for PowerPoint? Did they write it for Word and then copy and paste all that code into PowerPoint? No, they didn't. They used the library to complete the same objective, which is to spell check. So, static libraries. Now, any code written into a static library is for executable code being written. What does that mean? This means the static library is actually embedded into the program. It's not separate from the program. It's part of the program. Now, this is going to make the program slightly larger. How much larger? It depends on the size of the library and how much code is used to actually construct that library. If you make changes to the library, maybe you add a new subroutine, you have to recompile all that code because a change has been made. Anytime you're making an executable file, you have to compile all of it, and it needs to be error-free. Now, each program using a static library has its own copy of the library, so this can lead to a lot of RAM space being wasted. Well, what's an example of this? Think about spell check. Let's say Word has its own library that contains spell check, and PowerPoint has its own library that contains spell check. If I have a Word document and PowerPoint going at the same time, and both of those libraries are loaded that do the exact same thing, both of those are going to be loaded onto the RAM. There's no point in wasting that RAM when one library can accomplish the exact same thing. Now, PowerPoint and Word do not use a static library for spell check. They use a dynamic link library, which we'll talk about in a minute. Now, on the positive end, the executable file does not need additional files because the library is part of the code. You don't have to worry about making sure you have those libraries. You don't have to worry about one going missing because it's all part of the program itself. That is a static library. And on the other hand, you have dynamic link libraries. Now, you may have seen some .dll files on your computer. Anytime you see a file with the .dll extension, that stands for a dynamic link library. Now, these are libraries that are linked to the program, so they are not embedded, but they're accessed by the program that is using that library. Now, subroutines are not loaded into the RAM until a call is made by the program. So this is going to both save RAM space and also optimize it because it's only going to load onto the RAM when it is needed. Now, if you make a change to the dynamic link library, you don't need to recompile your program. And that's one of the benefits of using a dynamic link library. If you make a change to a static library, which is embedded into the program, you have to recompile it. With the dynamic link library, you don't. The library and the program are independent of one another, but they do work together. But you have to be careful, because if you change the subroutines in the library and how they work, your program may not be compatible anymore, and it could crash because it's not working how it used to. So anytime you make a change, you have to either roll out a patch update letting people know what changes have been made and how something works, or you can add things onto it without having access to the source code at all. And that's one of the benefits of a dynamic link library. Now, in a future video coming up very soon, we're going to be making our own dynamic link library so you can see how those actually work and how you can create your own library to reuse code. So make sure you're on the lookout for that. Now, you also want to make sure that all the dynamic link libraries are available that your program needs. The program needs to be able to access them. If it's missing, it could crash. Now, because multiple programs can use this, a dynamic link library can save RAM space, because remember, it's being accessed, it's not embedded into the system, and more than one program can use it simultaneously, such as spell check in Microsoft Word and PowerPoint. And that's just a simple example. Now, let's actually use a library. Using libraries is the best way to understand how they work. Now, we're going to write a program. If you're a returning viewer, welcome back. We're going to write a program so we can use it. If you're brand new to this channel, welcome. I hope you stick around and write this program with us. So we're going to write a program that does text to speech. The computer's going to read the word in our program, and it's going to speak it. And surely that code must be complicated. Not if we have a library. And guess what? We do. There is a text-to-speech library that we can implement that does that complex code for us. So let's write a program that will test a student's spelling skills. If you have a younger sibling or a younger person that you know, or anybody that's struggling with spelling, you can write a program that will help them. So let's load up a Windows Form application in VB.NET and see this text-to-speech in action and in a practical application. Now that we're in VB.NET, we can go ahead and start using that library. So what we're going to do is we're going to type in imports. It's going to be at the very, very top. We're going to do system.speech.synthesis. And we're going to run into an issue. You're going to see it's green, and this is one of the issues with the dynamic link library. When you use the math library in VB, it's loaded. You have access to it. You have a link to it. But not all libraries are readily available. So when we try to import it, it's going to say, hey, it can't find it. So here is what we're going to do. We're going to create a reference to it. You're going to click on Project. You're going to scroll down right here where it says Add a Reference. Go ahead and click on it. It's going to bring up this menu. We're going to be looking under Assemblies, and we can start scrolling down. And you'll see some things that we've used before, such as system.drawing. Over the summer, we made the Snake game, and we used that system drawing library. So these are all the different ones they have. They are in alphabetical order, and we're looking for this one, system.speech. So we're going to go ahead and check it. We're going to hit OK, and now that green line is going to go away, and there it is. Now we are going to need some variables for our program. We're going to need the answer. That's going to hold the answer that the user types in, and we're going to check it with the word that we select to make sure it actually matches up. But to do that, we need a words array, and we're going to front load that for testing purposes. We're going to start with apple, and you definitely want to spell it correctly. Berry. Let's use cherry. D, dates or date. And then E, let's do elephant. That is not a fruit at all. It's not following the theme, but that's okay. So we have apple, berry, cherry, date, elephant. They are in alphabetical order. They do not have to be. That's just what I used for testing purposes. You can add as many words as you want. You can also create a file, and then you can load the file when your program starts to actually load those words. Now we do need a word as a string. That's good, so we can get the word so the computer can actually say the word. Now we need a synthesis object. So we're going to do dim comp as new speech synthesizer. So we need that. That's going to be using the system.speech.synthesis library. So we need to create that. Then what we need is we need their score. We want to keep track of that and what their percentage is, or maybe let them know how many they got right out of how many they've done in total. We're going to go back to our design. Now we do need some buttons. We do need a text box to gather the spelling from the user and a label that keeps track of how many they've gotten right and how many they have attempted. So I'm going to fast forward to where all that is done, and then we'll go over the names for each of those and again what they do. All right, let's talk about everything we have here. Let's go ahead and bring up the properties window. So here we have the form. You can see we changed the text property of the form to spelling challenge, but we did leave it as form 1. We have a button. We called this one BTN new word, and we changed the text to say new word. Anytime we want to get the next word, we can do that. Here we have BTN repeat with the text saying repeat. If we don't hear the word or we want to hear it again, what we're going to do is we're simply going to click this button so we can hear the word again, not get a new word, but it to say the same thing. We have BTN submit. This is so the user can submit their answer that they're going to type into this text box. This text box is called TXT answer. Then we have a single label up here at the top that says score : 0. It is called LBL score. And then what we're going to do is use this label to handle the updating of their score, letting them know how many they got correct. All right, so let's go ahead and get into our code here. Going to close this properties window. We do need a couple custom methods. So what we're going to do is we're going to do public sub, and what we're going to do is we're going to do speak word. I can call this whatever I want, but speak word is so the computer can speak it. So we need to write the code to get the computer to say the word. So we're going to do comp, because that's my speech synthesizer, dot speak. What are we speaking? The word that is selected. And just like that, we are done. I have no idea where to even begin at this moment to write code to get the computer to say the word. However, because we have this library, the system.speech.synthesis, we're able to have access to code that does the complex part of it for us. And that's the benefit of using a library that we talked about earlier. Now we also need public sub set word. We need to set the word. And we're creating these custom subs that we have here so we can use them over and over again. So we're going to do R&D num as new random, and I'm going to do index as integer. And what that's going to do is it's going to pick a random number between 0 and the amount of items in my array. Right now we have 5 items in the array, but remember when we front load an array, it starts at index 0. So apple is index 0, elephant is index 4, not index 5. So let's go ahead and generate a random number and assign it to index. We're going to do R&D num.next. I want to have it pick 0. That's going to be my lower bound for it. And we say this is inclusive here. It's going to be included because the array starts at index 0. And I want to go to my words.length, which is going to be 5. Why don't I just use the number 5 instead of words.length? I can now add as many words as I want to this array and not have to come down here and update this code. If I change this to 5 and I add new words, I got to go up here. I got to count how many words there are. Then I got to come back down and change the number. I don't want to do that. I just want to do words.length. Now remember, the second number is exclusive, so 0 and to 5 will not generate a random number 0 up to 5. It'll do 0, 1, 2, 3, 4. So we say this first number is inclusive, this second number is exclusive. Once I have the random index, I have my word, because my word is going to be from the list of words at that specific index that was chosen. So those are the two custom subs that we're going to be using multiple times, and we can tie some of those buttons back to these methods. All right, so we need to program the Say New Word button first. I'm going to double click it, which brings me to my code. When they click on the button, what do I want to happen? Well, what I want to do is get back in the right spot, and I want to set a word, I want to speak the word, and I want to increment total by 1. So it's going to select the word, then the computer is going to speak it, and then that is an attempt. So I increase the total they've done by 1. The next button I need to do is my repeat button. When I repeat the word, all I need to do is call speak word. I don't want to select a new word. I don't want to change anything else. I simply want it to speak the word again. The last button is submit. So I'm going to do answer equals txt answer dot text. I want to go ahead and put that in the variable. If answer equals word, then what I want to do is I want to increment that score by 1. Then what I'm going to do is once I've incremented the score, I can go ahead and put that in my label. So my label score dot text equals, and that's going to be, and I'm going to follow the same format, score colon, and I want to put in my score, and I want to put in how many they got, or what their score is out of, and then the total. So just like that, we pretty much have everything. So less than 50 lines of code, and that's with some spaces in here. So let's go ahead, let's run our program. So I turned my volume up as loud as possible. That way you can hear the words when it is said. So we're going to click Say New Word.
Elephant.
And it shows elephant. If I wasn't sure what it said, I can repeat it again.
Elephant.
And it is elephant. So I'm going to type in elephant. I'm going to hit submit. And I'm 1 for 1. I'm going to go ahead and get a new word.
Cherry.
It is cherry. I can repeat it.
Cherry. Cherry. Cherry.
And it'll do cherry. So we want to make sure we are testing it to make sure it's not saying a different word. We hit submit and we're 2 for 2. I get a new word.
Berry.
Berry. But if I click get a new word again,
Date.
it went on and moved to a new one. So if I type in date, which is correct here, you're going to see we're actually going to go 3 for 4 because we had a new word. So what I want to do is I want to fix that. So what we're going to do is when we click on Say New Word, what we're going to do is we're going to do btn new word dot visible equals false. I want to go ahead and hide that button. Now when I click on submit, I want that button to become available again. So what I'm going to do is I'm going to do btn new word dot visible equals true, because they have that repeat button. I don't want to lower their score by them accidentally clicking new word. So now when we run it, we say new word.
Cherry.
And now once it's done and it has said that word, it goes, it disappears. We can repeat it.
Cherry.
It is cherry. So I'm going to type in cherry, submit 1 for 1. And now I can
Apple.
get a new word. I didn't hear what it said.
Apple.
It said apple. So I'm going to type that in. I'm going to hit submit. And then that new word comes back. If I hit say new word,
Date.
then it's going to generate that new word.
Date.
Repeat
Date.
does not increment it by 1. So I'm going to spell date incorrectly. Put it as DAT. And you can see my score still works. I can now say a new word. So that is a simple real-life application that can be used for anybody who's learning how to spell or maybe struggling with certain words. You're going to load those words into the array, and then you have a program that will check the spelling. It's not going to be any good to have a program that displays the word and you have to spell it, because then you see how it is spelled. But that's how you can use a library in a real-life application. Hope you guys found this video helpful. If you did, please take a moment to give it a thumbs up and subscribe to help the channel grow. And we'll see you guys in the next programming video.